Hello and welcome to Chapter 5, Section 9. We're starting to get down to some of the nitty-gritty details of slopes and y-intercept forms and things like that. We're going to look specifically at the slopes of parallel and perpendicular lines. The definition for parallel are two lines that go in the same direction on the same plane and they never cross. Doesn't matter how long it is, they're always going to be next to each other. And this is non-vertical lines because remember, vertical lines have an undefined slope, so they're in a whole different category when they go straight up and down like that. In parallel lines, they're going to have the same slope, but they're going to have different y-intercepts. It's really that easy. And they're going to spend 2 or 3 pages getting you to work with some of these. And what I need you to understand that if they have the same slope, they are parallel. Or they're the same line. Different y-intercepts means you've either moved it up or down, but they're still going in the same direction. However, on an axis, if you take this line and you make the y-intercept larger, you've slid that line up, but it's still parallel to the line before it. Got it? So now we're going to look at different lines, and the question is, are these lines parallel? Which lines are parallel to each other? So here we're going to look at this line with a 4/3 slope. And we're going to look at this line with a 4/3 slope. And this line crosses the y-axis at +3 and this one at -5. So I've taken this line, same slope, and I've slid it down to the -5 spot. I've slid it down 8 units because it takes 8 to get from +3 to -5. Does this make sense? Here I have a line y equals 2. That's a horizontal line going all the way across the 2. And I've taken that line because this line has a slope of 0, so that whole section of the equation is just gone. And I've slid that line down. Here also m equals 0. But now y equals -3, I have slid that 5 units down. Does this make sense? These two are parallel to each other, and these two are parallel to each other. Let's try a couple more sections. In looking at these, I have here a slope of 3. I have here a slope of -1/2. I have here something that's not in y-intercept form, and here something that's not in y-intercept form. Let's see which ones of these match. I'm going to subtract x from both sides, so I get 2y equals -x minus 4, and I'm going to divide everything by 2 so that y equals -1/2 x minus 2. There's an imaginary 1 right here. And I can take this 2 and I can make it here and I can make it here. So I've got 2 different things going here. And look, I've got a slope of -1/2. So these two are parallel. This one, y minus 5 equals 3x minus 3. I'm going to add 5 to both sides, and y equals 3x plus 2. I've got a 3 slope here, which makes it parallel to this one. Go ahead and try on page 362. Check it out, number 1, so that you can work this out for yourself. Push pause here, come back when you're done. So check it out, number 1. I've got a slope of 2 plus 2x plus 2. I've got a slope of 2x plus 1. These two are parallel. I've got y equals -4. And there doesn't have anything parallel to it. I've got x equals 1. This doesn't have anything parallel to it. So just these two are parallel. With 1b, I've got y equals 3/4 x plus 8. I've got y equals 3x. And this ends up being y equals 3x plus 5. So these two are parallel. And -3x plus 4y equals 32. I've changed around and it lo and behold, it ends up being y equals 3/4 x plus 8, which means it is parallel. It is actually the same line as this, because not only does it have the same slope, but it's also got the same y-intercept, which means it shows up exactly on the same spot. So these are identical lines. Now we're actually going to apply our math to geometry, and the question asks us to show that ABCD is a parallelogram. Now a parallelogram is a four-sided shape with opposite sides that are equal in length and parallel. Now equal means eventually somebody's going to ask you to do the distance formula in it. Luckily not this section. Right now we're just going to focus on, are the lines parallel? And they give you a drawing that they do much better than I do, but I like this to have it here because it gives us the points right away. Now, I know that A and D are both on the x equals -1 line, so this is a vertical line. And I know line BC are both on the x equals 4 line, so this is a completely vertical line. Because line AD and line BC, CB, these are both vertical. These are parallel to each other because they are both vertical. And that's just a reason. You can write that. That's fine. So two of our sides are parallel. We have to prove that the other two sides are parallel. So we need to compare the slope of AB, line AB, to the slope of line CD. And we're going to do change in y over change in x. So we're going to do 7 minus 5 over 4 minus -1. And we're going to do 3 minus 1 over 4 minus -1. So this slope, 7 minus 5 is 2, 4 plus 1 is 5. This slope, 3 minus 1 is 2, 4 plus 1 is 5. We have the same slope, and that means they are parallel. So we have proven, we have shown that ABCD is a parallelogram because opposite sides are parallel. Okay? There's another parallelogram on Check It Out number 2. Try that. Pause here. Try it because it's not hard, but it is kind of complicated. There's some steps here. So pause the video here, give it a shot, and come back when you're done. So for problem number 2, line AB is horizontal because they're both on y equals 2. And line CD is horizontal because they're both on y equals -3. And because they're both horizontal, they're both parallel. Slope of AD is 5/3, and the slope of BC is 5/3. That makes these parallel also, which means this is a parallelogram. Next, we look at perpendicular. Perpendicular lines are lines that intersect to form right angles. Intersect means they cross, and right angle means 90 degrees. Two lines are perpendicular if the product of their slopes is -1. That means you find both the slopes and you multiply them together, and the answer should be -1. If it's not, they are not perpendicular. So let's look at the lines that they give us and see if we can identify the slopes. This is a vertical line. All of the points on the line, x is -2. This is a horizontal line, which means these are perpendicular. Here we have a slope of -4, and here we have to find our slope. Y plus 2 equals 1/4 x plus 1/4 minus 2 minus 2. Y equals 1/4 x minus 1 3/4. So 1/4 here, if we said -4, and it's the same as 4 over 1, times 1 over 4, these two cancel each other out, and these two cancel each other out, and essentially 4 divided by 4 is 1, and 4 divided by 4 is 1, and I end up with an answer of negative 1. So these are opposite slopes, which makes these two lines perpendicular. So you have to find both slopes and then multiply them together to get your answer of negative 1. Give that a shot on Check It Out number 3 on page 363. Pause the video here and come back when you're done. Number 3, they give us 4 lines again. We have a y equals negative 4 and an x equals 3. One is horizontal, the other is vertical. These two are perpendicular, and then they give us the others. And we have to figure this one out to get to y equals 5x plus 26. And the other line they give us is y equals negative 1/5 x plus 2. And 5 over 1 times negative 1 over 5 is going to give us negative 1. So these two are perpendicular as well. The next thing they're going to ask us to do is to show that triangle PQR is a right triangle, which means it contains a 90-degree angle. And the first thing I would urge you to do is look and find which one you think is the 90-degree angle. That one looks more like a 90-degree angle than either of the other two. Because what you need to do is pick the two that you want to compare the slope to. And if you don't get it right, you need to do the slope of that third line. So what we're going to do is we're going to compare the slope of this line and this line. Line PQ and the slope of line QR. So PQ, change in y over change in x, 3 minus 0 and 3 minus 5, and the slope of QR, whoops, that was QR, shoot. All right, a little confusing. PQ is 3 minus 1 and 3 minus 0. So 3 minus 0 is 3, 3 minus 5 is negative 2, 3 minus 1 is 2, 3 minus 0 is 3. And when we look at these slopes, negative 3 over 2 times 2 over 3, those two cancel and those two cancel, and I'm just left with that negative 1. So this line and this line form a right angle. Pause the video here to do Check It Out number 4 on page 363. Number 4, I guessed wrong the first time I did this. I did the slope of PR and the slope of QR because I misread my thing and I was actually doing this line twice. And then I did the slope of PQ. And you can see that the slope of PR is negative 1/2 and the slope of PQ is 2. And negative 1/2 times 2 over 1 is going to equal that perpendicular slope answer. So the angle between PR and PQ, this angle right there, that's our 90-degree angle.